Hi folks. Today I asked you guys to solve some problems that were a bit more challenging, and I wanted to post a little bit more of evidence rather than just putting up the answers. So I'm putting up these videos. So the first question I asked you to do was this one, which was number 6 out of the review test or the student test. And it says a student uses a clinometer to measure the angle of elevation of a sign that marks the point that is 50 meters above the ground. So here's the pole. And there's a sign right around here that's 50 meters high. And it says the angle of elevation is 37 degrees. So this makes a triangle right here. And we've got the student. The student is 1.5 meters above the ground. So the angle of elevation is actually measured from their eye line up to create the triangle. She then measures the elevation to the top of the tower and finds that to be 49 degrees. So that's all the way up to the top. So it now asks us, the question is determine the height of the tower to the nearest tenth of a meter. So it wants to know how tall is the tower, and it tells us the diagram is not to scale. So where should we start? All right. So the first thing we want to do is calculate the side of this triangle here, because the side isn't all the way to the bottom. So we have to go 50 meters, subtract the 1.5 for our height, and the side of this triangle here is actually 48.5 degrees, 48.5 meters. I'm also going to say that let x be the distance from her to the pole. So, whoop, a little far. So, if we take our angle here, which is 37, we're looking for the side x. We know that this right here is 48.5. This sets up as an opposite and an adjacent. And we have an angle, so this is a tan ratio. So we say the tan of theta is equal to opposite over adjacent. And we fill in our values, 37 and 48.5. So we say the tan of 37 degrees is equal to 48.5 divided by x. So now we got to do some algebra to sort of solve this out. So we're going to multiply here by x, canceling out the x's. We also have to multiply this to the other side. So we end up with x tan 37 is equal to 48.5. We then divide both sides by the tan of 37, and we get x is equal to 48.5 divided by the tangent of 37 degrees. I use my calculator, making sure it's in degrees, and I get a solution there that tells me that x is 64.3616 meters. So that means the girl here, the student, she is standing 64.3616 meters from our tower. Cool. So now we can see that this x, this value, or this base, is equal in both the smaller and the larger triangles. So we've got the bigger triangle and the smaller triangle, and x is the same in both. So what we want to now do is try and figure out how tall is it for the larger triangle. So we're going to call that y, and we'll say let y be the height of the pole above her height. So everything above her height is going to be called y. And for visual reference, if you look here, it's marked in blue, y all the way up to the top from here. Okay. We're also going to use the angle that is 49 degrees. And so this also sets up as a tangent ratio. So we say the tan of the angle is equal to opposite side, or the y, divided by the value of x. We set that up. The tan of 49 degrees, which is our new angle, is equal to y divided by 64.3616. The value's in blue. And I'm going to start by multiplying both sides by 64.3616. They cancel out here, and I end up with 64.3616 times the tangent of 49 degrees. And that's going to give us our value for y. And in this case, that equals 74.0396 meters. Awesome. So what does that tell us? That tells us the distance from here to here. But the question actually says, how high is the pole or the tower? Well, the last step is we're going to take y, and to that we're going to add her height, and that will tell us how tall the pole is. So we do that. 74.036 plus 1.5 is equal to the pole. So the pole, rounding off, is 75.54 meters. And the last step is to give the final answer in a statement. So I say that therefore the pole is 75.5 meters tall. And that's the solution to one of the questions for homework. If you have any questions, send me an email or a message over Classroom.